In 1963, Martin Schmidt discovered the first observed quasar. From Earth, the quasar looked like any other star. What was so peculiar, though, is that it emitted radio waves, which is where they get their name. At first called a quasi-stellar radio source, the quasar was more than 1 billion light-years away, meaning two things. One, it was really, really powerful to be that visible from this far away. Two, it existed long enough ago, seeing it may be a glimpse backwards into what earlier stages of our galaxy and others like it may have been like. A quasar is a type of AGN, or active galactic nuclei, that is extremely luminous, made up of a few components. It is a massive black hole that is 100,000 solar masses to billions of solar masses large. Surrounding the black hole is large quantities of gas, called the accretion disk, which is what the black hole is consuming. Where this gas comes from is still unsure, but one possibility is that quasars develop after two galaxies collide. As the gas is consumed, the friction of its movement creates heat, which is then emitted back into space as light and radiation. Quasars are different from black holes and special among AGNs because of their size, the amount of material they can consume, and their jets, radiation shooting out of both sides of the quasar. But how do quasars impact the habitability of HTPs? A few ways. Indirectly, they can lead to ionization and chemical changes, destroying planets' ozone layers, exposing them to radiation from their star. Since different molecules absorb and protect from radiation differently, ionization could be a major factor in if a planet is able to maintain a habitable temperature, keep liquid water on the surface, and be protected from radiation. However, there are some factors that play into the effects quasars can have on nearby planets and stars, one of which is dependent upon what type of galaxy and where in the galaxy the exoplanets reside. There are 4 different types of galaxies: spiral, elliptical, lenticular, and irregular. Spiral, lenticular, and elliptical galaxies are very similar. They all consist of an SMBH in its center and have a bulge. Spiral galaxies also have a stellar halo. The highest concentration of stars is placed in the central parts and decreases exponentially when moving outwards. Therefore, a higher fraction of stars will be affected by the AGN closer to the center of the galaxy. Lenticular galaxies are an intermediate type between spiral and elliptical galaxies. They do not have distinguishable spiral arms, which means they also have a low fraction of star formation. Irregular galaxies lack the presence of any nuclear bulge or disk. Thought to once be spiral or elliptical galaxies that were deformed by an uneven external gravitational force. Therefore, all stars, gas, and dust are spread randomly throughout an irregular galaxy. In conclusion, the amount and concentration of stars, gas, and dust differs in each type of galaxy. Where planets are within the galaxy can change what effect quasars can have on them. But they aren't all bad for habitability. The quasars can help to clear out excess particles and gas in the galaxy, which could potentially help habitability later down the line. It's a give-and-take situation where quasars do consume a lot, and they do emit tons of radiation, but that could act as a filter, clearing the way for habitable planets to develop life later on. Quasars are a relatively new area of research, but the role they play and the sightline they give us back to earlier stages of the universe will continue to be important to our understanding of extraterrestrial life.